viewers, you're welcome to my YouTube channel, Maths with Adevik. I'm Victor Adewale Adeleke. Yeah, my major focus is just to teach you mathematics from the onset, even up to tertiary institution. If you are yet to subscribe to this channel, do well to subscribe, like and share to your friends and relatives so that when I post helpful materials like this, you will always and certainly get notified. Okay, now we have a question here we want to quickly solve. We want to show how geometry and algebra intertwined to each other with each other. Sorry. So we want to solve a question, a quadratic equation of the degree 2, a polynomial of the degree 2. So we want to see how we can puzzle out the solution to this question. What is the value that will be substituted into this to actually become 0? Okay, let's rewrite this to become x squared plus 10x equals negative 16. So let's rewrite it to be like this. So what are we going to do now? What are we going to simplify to become like this? Now note, we want to make this a complete square. So we want to look for a number that will be added to this number that will make it a complete square. Now I want to take you through the geometry of this particular stuff so that we can see what we are actually talking about. Let's understand the concept of completing the square. Okay, now let's try to write this using this diagram that was given, that I drew out. Okay, this is a square. Okay, I mean this from here, from this point to this point, to this point, and to this point. This is a square, a complete square already. Now, okay, let's say this is of side x and this place is of side x because it's a square. So automatically it means the area of this whole place here is x squared. Okay, now if the area of this place is x squared, now we have 10x here. So this is a complete square that we already had, but now we are adding 10x to it. If you add 10x to this, it will imbalance the nature of the square, because adding 10x to it will make it no longer a complete square. So let's see, if you are adding 10, don't say 10x, let's say 10. Let's say this length from here to here, let's assume it to be 10. Now if you are assuming it to be 10, now since we know that from here to here is x, and also from here to here is x, so automatically which means this is a rectangle, so the length from here is x and the length from here to here is 10. So therefore the area of this rectangle is going to be 10x, which we already have here. But now this is 10x, now you can see how big it is. So the idea behind completing the square is we are to half this 10 now. We will half it. When you half 10, you get what? 5. So that's why you saw the demarcation there. I had to half it. So if you are halving it, this will leave. So we halved it and took one of the half and added to this angle. That is the concept or the conjecture behind completing the square. So if you are adding it here now, then this place, don't forget you've halved 10. So here is 5. So automatically here is also what? 5. And here should be 5 or must be 5, because we took half of 10 and added. We used it to complement both sides. That is the completing. You are complementing with both sides with what you've halved. So by that, you can see that if you do that, you will be having a space left. So how are we going to complete the square? That is the idea. So completing the square, let's draw a line to complete the square. So since we already know that here is 5 and here is also 5, so automatically the whole area here is going to be 25 Newton. Or 25 units, 25 units. So automatically this 25 units is what should be added. That is the area of the square that was added to complete the square that we had. So automatically we are going to come out with x squared plus 10x, then plus what now? Plus 25 units, which was added, the new square that was added of side 5 that was added to complete the square. So automatically, don't forget to change this an algebra. Whatever you had to the right hand side, I to the left hand side. So we have minus 16 plus what? You added 25 to this place. So we also need to add what? 25 to the other place. Doing that, everything here you can see this is a complete square now. So what is the square? Now the square is complete. You can see the length from here to this point. The length from this point to this point would become x plus 5. X plus 5. Also the length from here to here becomes x plus 5. So also here to here x plus 5. So now if the length from here to here is x plus 5 and the length from here to this point is x plus 5, you can see the square is complete now. So automatically this becomes what? A complete square, x plus 5. So x plus 5 is now the side of the square squared equals to, you know why we put the square, because why? Because it's now, don't forget, the area of a square is length times length, which is what? L squared. So that's where we got that squared from. So the side is now x plus 5. Each of the side are x plus 5. So you squared. I'm trying to explain it explicitly so that we can understand what is going on there. So minus 16 plus 25 now becomes 9. So when you remove your, so you definitely are going to come out with x plus 5 equals to what? Positive negative 9. So x plus 5 is equals to positive negative 3. Yes. So moving that, you have x is equals to what? Minus negative 5, positive negative 3. And this is equals to, this is x now. This was x you are looking for. So x is equals to positive negative 3. Don't forget, it is a polynomial of the what? Of the degree 2, of the degree of 2. So automatically the solution is going to be 2 answers. So we have what? This can be written as what? Minus 5 plus 3, or minus 5 minus 3. And this will result finally to what? We come out with minus 2 or what? Or minus 8. These are the solutions to the what? To that beautiful question. If you are yet to subscribe to this channel, do it to subscribe, like and share this video. It is very important that whenever I post helpful materials like this, you will always and certainly get notified. Stay tuned.